What the hell is a linked list and how is it different from arrays? And why is everyone so scared of it? So let's say we have these two cupboards over here. One is completely empty and other has some items inside of it. And these cupboards over here signify our memory, and these stack of clothes signify the elements that we're supposed to store inside of our memory. So let's see. We're supposed to store these inside of this empty cupboard. So I'm gonna put it every cloth above each other. And okay, we cannot store this anymore. This cupboard is filled. So okay, this one got left out because our memory is full right now. And this signifies our array over here. Since our array, we store all of our items in a linear fashion at one place inside of our memory. But let's see, this other cupboard also signifies our memory, but this memory has some items already kept in different places. But we don't have a place where we can store all of these, clothes simultaneously or in a linear fashion. So what linked list helps us to do is this. We can keep one stack over here, one stack over here, let's say, other stack over here. And we can keep a tag on each of these stacks that, okay, next stack is kept over here. And over here I've kept a tag that, okay, you can find another stack that is above your compartment, that is right over here. So this is what a linked list is all about. It helps us save a lot of space inside of our memory, just like it did over here. In our arrays, we cannot do this. We cannot store our elements in different parts of the memory and link them together. But in our linked list, we can do this. Let's see a better visualization of a linked list. So this is what we use to denote our linked list, this structure right over here. And as you can see, our linked list is made up of these small items, which we call node. And each linked list has a head node and has a tail node. But what is this node anyway? So in JavaScript, we denote a node by using a class which we call node, or whatever you want to call it. And inside of it, we have a constructor which has two things, a data and the address to our next node. In a node, you can see we can store our data over here, which can be anything like number, string, whatever that you want to keep over here. And we have a next field which contains the reference to our next node. So as I mentioned over here, inside of our cupboard, we kept a tag on each and every cloth, right? That where is the location of the other cloth. That is exactly how linked list works. In each of these nodes, we have the location of the next node in our memory so that we can, traverse through this linked list, or we can go through each and every node in this linked list. Also, in a linked list, we can only move from left to right, and we cannot move in a reverse manner, because obviously a node doesn't know the size of a linked list and how far it is supposed to go. The only information a single node has is the reference to its next node, and a particular node doesn't know from where it came from, so it doesn't have the reference to its previous node. So we cannot move from right to left. We can only move from left to right or from start to end inside of our linked list. And every single node in this linked list has a head node and a tail node. So the first node is called a head node and last node is called a tail node. And the very last node of our linked list doesn't have any other node after it, so that's why we are pointing it at null. Let's better understand it by implementing it in JavaScript. Let's understand how we can insert a new node, how we can delete a node, how we can get a size of a linked list, etc. But before moving forward, I would like to mention my DSA sheet which I announced recently in my previous videos. And I've received so many messages from you all telling me how many times you have encountered these questions in your DSA interviews. Therefore, I would highly recommend you all to go and download this DSA sheet from the link in the description down below, so that you can avoid hundreds of useless questions on LeetCode and do only those which actually matter for your interviews. Okay, so let's see. So the first thing obviously that we are supposed to do is to create a node for our linked list. So as I showed you earlier, I'm going to create a class called node, and inside of it, I'm going to have a constructor which will take a item that we're supposed to store, and it will store it inside of this dot data equals data. And obviously, as I mentioned, we're going to have another variable which is going to be next, and next will point to the next node. But in this case, we don't have any node, so by default, it's going to be null. Alright, cool. So this is our node class, which is being initialized with this data. Now let's go on and create our linked list class. So I'm just simply going to name it linked list. And this will also have a constructor, and I'm going to initialize with this dot head. By default, if you notice in our whiteboard, we had a head, right? But in this case, we don't have anything inside of our linked list currently. So this dot head is going to be null for now. When we're going to add something to it, then this dot head will point to the first node of our linked list. All right, cool. Now let's write our first method, that is adding to the very top of our linked list or adding to the head. So I'm going to name it add first. So obviously it will take our data, and let's first see visually how this works. So let's say we have this linked list over here and we're gonna insert something at the head. So okay, let's insert 93 on the head. So I'm gonna press go and you're gonna see. So we created a node called 93 and we're gonna point it to our head, and then we will assign the head variable to this because now it's at the very top. So this is no longer the head, this will be the head. So yep, that is what we're gonna do over here. I'm gonna create a new node. Let's say const new node, and this is how we basically create an instance of a class in JavaScript. If you want me to create an in-depth video on class and constructors in JavaScript, let me know in the comments down below. So if we have a class over here, this is how we create a new instance of a class or new object of a class, and we're gonna initialize it with the data, this data that we're supposed to add inside of our linked list. And then simply I'm gonna say new node. If you remember, we had two things: a node has a data and it has a next variable. So new node dot next will point to the current linked list's head. So whatever the head of our linked list is, that it was 22 in this case. So I'm gonna say this dot head. So now it's pointing to this variable over here, but at the end we're supposed to make this our head. So now I'm gonna say this dot head should have new node inside of it. As simple as that. And I don't know why people are so much scared of linked lists. It's so easy, it's so straightforward. You're gonna understand as I move forward in this video. I'm gonna show you how you can insert at the very last, insert in the middle, remove from the middle, remove from the last, from the top, every single method. Keep watching this video. So okay, let's go on. Now I'm gonna create an add last method. Simply, this will also take a data. Cool. Let's first go on and understand how it works visually. So I'm gonna go inside of insert, and yeah, after tail, that is at the very last, right? Okay, I'm gonna take this value, I'm just press on go. So simply what we did over here is we traversed through our linked list, we went to each node one by one, and we kept going forward until we found a node which was pointing to null. And then after that, we pointed that node to the node that we're supposed to add at the very end. So let's see the code. So I'm gonna create a new node, obviously, new node, which with this data over here that we're supposed to add. Then first of all, we're gonna check is there something inside of it linked list or not. So our head was by default null, right? So if there is nothing inside of this linked list, obviously we're gonna just keep it at the very first element, that is at the very head of our linked list, right? So I'm gonna check if there's nothing inside of this head, then I'm gonna say this dot head is equals to simply this new node over here. It's like that, and I'm gonna say return. Cool. But if that's not the case, I'm gonna traverse through our linked list now. So how do we do that? I'm gonna take a variable called current, which will be by default this dot head, that is the first element of our linked list, this one. And I'm gonna run a while loop until we reach a node which has next as null. So I'm gonna say current dot next over here. That is, if we have something inside of the next, that is it's not null, then we're gonna keep going forward. And I'm gonna say current equals current dot next. So what this will essentially do is every time we go inside this loop, it's gonna assign the next node inside of this current variable. So first current is this, then in second loop current is this, third loop current is this, and as soon as it encountered the next to be null, it's gonna break it. And now the current is on this node over here. So now simply we can say current dot next equals this new node, right? So all right, current dot next is equals new node. As simple as that. Now let's see how we can add something inside of our linked list at a certain index. So I'm gonna create a new function over here called add at, and this will take a data and an index. So index is where we're supposed to add our data. So okay, first of all, first thing first, the index that is provided over here, we need to check if this is valid or not. So I'm gonna check if I'm gonna put a condition over here that if index is less than the size of our linked list and it's more than 0. So if it's between that, only then we're going to do something. If it's not, then we're going to say invalid index. So, okay, I'm going to say if index is less than 0, if it's less than 0, or index is more than the size of our linked list, that is this dot size. But we don't know what this size function is, right? We haven't created it yet. So you know what? Let's create this first. So I'm going to say size, and inside of it, we're going to do the same thing that we did over here. So I'm going to copy it, but this time, every time we go through a single node, we're going to count it. So we don't need this one. I'm going to take another variable, let count equals 0, right? Let current is on this dot head, and while current dot next has something, we're going to do count plus plus, or we can also do current over here, and at the end we're going to return the count. As simple as that. Let's go back to our add at, and now this is valid because we have defined this size over here, and inside of it I'm gonna throw the error. If this is the case, if it's less than 0 or more than the size of our linked list, I'm gonna say console.error to be invalid index, and I'm gonna return. Cool. Now what do we do after it? Let's understand it visually. So let's say we have this linked list and we're supposed to insert at the third position 21. Okay, let's go. So we're traversing it one by one, and okay, over here we're supposed to insert our element right over here. So what do we do? First of all, we're gonna point our new node that we have created over here to this node over here, and then we're gonna point this node to our created node. So you can see first we pointed it to this one, and then we pointed the other node, the previous node, to this one over here. I'm gonna first of all create a new node, obviously, since we're going to add it. So this is the line that we're going to use again. So just like that. And after it, I'm gonna say if index is equal to 0, that is, we're adding another edge case check over here, that if it's 0, then obviously it's going to be added inside of our head, right? So I'm going to say new node dot head. Basically, we're going to use this same code over here. Where is it? This one. This one I'm going to copy it and I'm going to paste it. Node dot next, this dot head, and this dot head will be new node, and I'm going to return. But if that's not the case, what are we going to do? We're going to traverse through this linked list. So I'm going to say let current equals this dot head, and it will keep the track of our current node. And now I'm gonna run a for loop which will start from 0 and it will go to index -1. Inside of it, I'm gonna do current equals current dot next, just like we did over here. But in this case, simply what we are doing, we're going to this index -1. That's it. We're not supposed to go to the very end, right? We're supposed to go to this index. When this index is found, then we're gonna add our element over here. So okay, at this point our current index is found. So simply I'm gonna say new node dot next equals current dot next. So if you notice over here, this was the current, and we're supposed to point this new node to this. And how do we know which node is this? We're gonna simply say, okay, whatever the next node of this was, I'm gonna point to that one. So at one point, if you noticed, both of these were pointing to the same node over here, right? So that is what we're done over here. New node dot next is equals to current node dot next. But now we're supposed to point this current node dot next to this one. So I'm gonna say current node dot next to new node equals new node. Just like that. That is all we needed to do to add a node in between of our linked list. Okay, now next let's see how we can remove an element from the top of the linked list. So I'm gonna say remove top, and inside of it, simply first of all I'm gonna check the edge case. If there is no head, so I'm gonna say if this dot head is null, then I'm gonna simply return it. No need to do anything. But if there is a head, I'm gonna say this dot head equals this dot head dot next. So what have I done over here? Let's see. So let's see if we're supposed to remove this head over here. Simply, what are we supposed to do? We're supposed to take this head, and we're supposed to point it to this one over here so that this one ceases to exist. This will no longer exist, right? So this is how you remove something from the top of a linked list. Let's see how you remove from the end of a linked list. So remove last. It's actually going to be similar to this one over here, add last. So I'm going to copy this code and I'm going to show you how it's same to this one. So we're not going to create a new node, so I'm going to remove that. We're going to check if this dot head doesn't have anything, then it's going to simply say return, and then we're going to traverse through our current. But over here we're not going to check current dot next, we're going to check current dot next because we're supposed to stop at this position over here, because we're supposed to remove this element from our linked list, right? So if we stop over here, we can remove it by pointing this node over here to null. So okay, while current dot next is the case, then I'm going to do current dot next, and as soon as it reaches this element over here, it will stop here, and I'm going to simply do current dot next equals null. As simple as that. Now let's go on and see remove at. If we're supposed to remove at a specified index in our linked list, so remove at, and obviously we're going to provide an index variable over here, and again this will be very similar to this add at. So I'm going to copy this code, paste it over here. We're not going to create a new node, so I'm going to remove that. So first of all, I'm going to say if index is less than 0 or more than the size, obviously invalid index, we cannot remove it. But if index is 0, that is if it's at the head of our linked list, then simply I'm going to say this dot head equals this dot head dot next. That is what we do to remove something from head, right? So yeah, that is what I'm going to do over here, and I'm going to simply return it. But if that is also not the case, then I'm going to say let current equals this dot head, and I'm going to reach to that particular index by traversing through it. So simply similar to that, I'm going to do that, and at the very end, when we reached that index, I'm going to remove this. I'm going to say if current dot next has something, then current dot next equals current dot next dot next. So what have I done over here? So let's say if we're supposed to remove this one over here, so if I reach this index, I can simply ditch this one and point directly to 43. So this will then cease to exist. So inside of our linked list, if we're supposed to remove this one, I can just simply point my next to this over here. Then this will no longer be a part of our linked list now. So this is how you remove an element from a specified index from a linked list. The very last function of our linked list is printing the linked list. So I'm going to say print, and simply to print the linked list, we're going to traverse through the linked list and print every single element. So let current equals this dot head, and I'm going to say while current has something, then do console log current dot data, and we're gonna move the current to the next one after printing the current data. So current equals current dot next. Cool. And that is all. That is how our linked list looks like. Let's go on and try to run this. So I'm gonna create an instance of this linked list class. How you do that? You do const linked list, or whatever that you want to name it, equals new linked list. Okay, let's go on and add some item to it. I'm going to say linked list dot add first. I'm going to add, let's say 5, then I'm going to add 3 and 8. Let's print our linked list and see what do we get. So linked list dot print, and I'm going to go to my terminal and say node linked list.js. Okay, we got an error over here. Linked list is not defined. Oh, okay, so this is spelling mistake. Okay, now let's try to run this again. Yep, you see, we added 5, 3, 8, and it printed it accordingly. 8 was added at the very last, so 8 should have been at the head, so it was at the head. Let's try to add something at the very last. So add last, and I'm gonna say 6. So this should have 6 after 5 now. Yep, that is what it did. Let's try to get the size of our linked list. So after I've printed it, I'm gonna console log this linked list dot size, and yep, we get 4. the size of our linked list was 4. I'm gonna say something like size equals, so that it's better to see. Yep. After that, let's try to remove something. So I'm gonna say linked list dot remove top, and this should remove 8 from our linked list. Okay, it removed the 8 and now the size is 3. Let's try to add something at some specified index. Add at, and we're supposed to give some index, let's say 2, and I'm gonna add 8 at 2, second index. So let's run this, and yep, you see we got 8 added at the second index. Similarly, we can remove something from the last, so it should remove 6 now. That's what it did. We can remove something from a specified index. Let's remove 8 from it, that is from the second position. 8 should have been removed now. Yep, it is removed. So you see how easy it was to implement linked list in JavaScript. Now let's go on and see some of the most frequently asked interview questions on linked list in our DSA interviews. Okay, so I opened my DSA book over here, and if I scroll down to the content, we can see we have linked list over here, and I'm going to click it. So yep, we have all of the list of questions. You can download this ebook by clicking the link in the description down below, and you can access all of these questions over here as well. So I'm going to click on this Palindrome linked list, our first question, and I'm going to open it in a new tab. So the question says that we've been given the head of a singly linked list, and we have to return true if it's a palindrome or false if it's not. So first of all, if you notice something, in real world problems, in real world DSA problems, we're not supposed to create our own linked list every single time. We are given a linked list, or more specifically the head of a linked list, the starting point of a linked list, and then we're supposed to solve the problem that is provided to us. So in this case, a linked list is already made, so you can see the description over here that this linked list contain this dot val, as which will contain the value of our linked list, and this dot next, which will contain the address to the next node of our linked list. So yep, we've been provided the head over here, and then we're supposed to work on it and tell if it's a palindrome or not. So we have been given this example over here. This is our linked list, and if you read it from reverse as well, it will be 1 2 2 1. But in this case, this is 1 comma 2, but if you read it in reverse, this will be 2 comma 1, which is not a palindrome linked list. So let's see how we can do that. So inside of this is palindrome function, I'm going to take two strings, string 1 and string 2. Both will be empty for now, and then I'm going to take another variable called node, and inside of it I'm going to store our head, because this node will be used for traversing through our linked list. If you remember, we used current variable in our VS Code when I was explaining the linked list. In this case, we can use node or current, whatever that you like. So what our approach is going to be over here. So what I was thinking is, we can traverse through these items one by one, and we can add it to this string. So let's say if I'm taking for string 1, I'm gonna encounter 1 first, so I'm gonna add 1, then 2, then 2, then 1. But for the string 2, what I'll do, when I'll encounter this 1, I'll add 1 over here. Then when I'll encounter this 2, then I'll add 2 before this 1, and then again 2, and then 1. So that in the end, we will get a reverse linked list over here. Then we can compare both of the strings and tell if it's a palindrome or not. All right, let's get started. Then I'm gonna run a while loop over here, and this while loop will run until node encounters a null value. And inside if I'm gonna say node equals node dot next, just like we understood in the case of that current variable, right? So yeah, this is what we will do. And for each iteration, as I mentioned, what I'll do for string 1, I'm gonna use backticks over here and template string, and inside is I'm gonna say string 1, whatever the previous value of this string 1 is, and add the current value of the node. So node dot val, just like that. Same thing I'm gonna do for string 2 as well, but there's going to be just one difference. So for string 2, I'm gonna put it after this. So it's gonna be string 2. Yep, that's it. That is all we need to do, and in the end we will get a reverse string over here. This will keep adding the values before the already added value. Now after that, I'm gonna return if string 1 is equals to string 2. That is the boolean value, if these are equal or not. Let's try to run this. All right, it's been accepted. Let's try to submit it. Amazing. Our question was accepted successfully. Let's move on to the next interview question. So the next question is to reverse a linked list. Now we already saw a way to reverse a linked list, but in this question I'm gonna tell you another way of reversing a linked list. So let's open it in new tab. We've been given the head of a singly linked list again, and you have to reverse the list and return the reversed list. Alright, so you can see the example over here. This is our linked list and we have to return it just like that in a reverse manner. Another example, and if we have empty linked list, we're just simply gonna return the same thing. Okay, so we have been given this function over here called reverse list and a head as a param. And again, for this head as well, this will be this dot value which will store our value, and this dot next which will store the reference to the next node. So first of all, what I'm gonna do, let me just write out the code over here, then I'm gonna explain you what it exactly does. So I'm gonna take a variable priv which will be by default null, and another variable called current which will be by default our head node, because this is what we will use to traverse through our linked list. Okay, I'm gonna run a while loop until current is not equals to null. So now first of all, what we will do is we will create a next node variable which will contain our next node basically. So current dot next. After that, what we will do is we will say current dot next equals to previous, and then the value of previous will be equals to our current node, and then current will be equals to the next node that I already stored over here. Okay, so what have I done over here? Let's see. I'm gonna copy this code. So first of all, the value of next node will be current dot next. So current was, as you already know, it was pointing to the head. So we stored the value of next node. Basically, we're taking the backup of wherever this current is pointing to right now inside of this next node variable. So next node is over here. So now we can easily manipulate the value of current. So current dot next will be equals to previous. So obviously, since we are supposed to reverse this first head will now be pointing to null, because the last node always points to null, right? So this will be pointing to null now. So the next for this will be pointing to previous, which was null, right? Now previous will be equals to current. So now we will point previous to current, which was this one, and then we will move current to our next node, since we had already taken the backup of our next node over here. So we will point to this one over here, right? Now in our next loop, again same things will happen. Next node will be equals to current dot next. So now current dot next is this one. So okay, we're gonna move next node over here, fine. And then I will say current dot next will be equals to previous. So current dot next, that is this one, will be equals to previous, and previous was pointing to this one. So now this will be pointing to the previous linked list. So I'm gonna say it's pointing to this one over here. Then previous will be equals to current. So I'm gonna move previous over here, and then current will be equals to next node. So since the loop moves forward, so I'm gonna move current to the next node. Again, I'm gonna repeat the same process. Next node will be equals to current dot next. Okay, current dot next equals previous. So this will be pointing to wherever previous was pointing, that is over here. Then previous will be equals to current, just like that. Then current will move to the next node. Then again, same thing will happen. This will move over here. This will point to here. This will move over here. And then current will be equals to next node. So did you notice something? What just happened over here? This is pointing to this, the previous node, previous one is pointing to this one, this is pointing to this one, and this at the last is pointing to null. So we have successfully reversed our linked list just like that. And in the end, we can simply return the previous, because previous is pointing to this one, and this will be considered as head now, this last node over here. So I'm gonna say return previous. And that's it. That is all we needed to do. Let's try to run this. Awesome. It has run successfully. Let's try to submit this. And our code was accepted. Awesome. Let's move to our next question. Okay, for our next question, I'm going to pick this. Delete a node in a linked list, because we have already done this one. So this should be very easy. There's a single linked list head, and we want to delete this node inside of it. So we've been given the specific node that we have to delete inside of this linked list. But we will not be given access to the first node of the head. So we've been directly landed on that particular node that we're supposed to delete. So for example, if this is our linked list, they have given the reference to this node. Let's say, for example, this node was to be deleted. We've been given the reference to this node over here. So let's see how we can delete that. If we scroll down, we can see, yep. So if this was the linked list, we've been given access to this node, and we have to make sure the linked list looks something like this after our job is done. Here you can see an example as well. So okay, this is going to be pretty easy. What we can simply do is, so let's say if this was the node, we can say node dot value will be node dot next dot value. So what simply we have done is, for this we have assigned the value of the next node, that is 1 over here. So now this will become 1 as well. So if we take an example here, 4 5 1 9. So we've changed the value of 5 to 1. Okay, just like that. And in our next line, what we will do, node dot next to node dot next dot next. So now we want this node to be pointing on dot next, that is this node will be pointed to 9. So instead of this node, this will be directly pointing to 9, which will result in this node being removed from the linked list, just like that. And yep, this is how you delete a node from a linked list. It was that easy. Let's try to run this. Oh, sorry, this should be val, not value. Yeah, let's run this again. Okay, let's submit it. Great, this one was accepted as well. Awesome. Now I have a side question over here. So what if you are asked to clear a linked list? So let's say I have a linked list over here, and we're supposed to clear the linked list, the complete linked list. What you can do over here? So what you can simply do is, you can point the head node to null, directly to null, or maybe I can create a null over here, just like this. That is all you need to do. And code for this can simply be, you will be provided the head, right? So this dot head equals to null. That's all. That's all you can do. So just a heads up question that I wanted to mention. So the next question is to remove nth node from the end of list. Okay, let's open this. Now this one is a little bit tricky question, so let's try to understand it properly. So until now, what we have seen is we wanted to remove the nth node or ith node, whatever, from the start of the linked list. But in this case, you have to remove it from the end of the linked list. And as I already mentioned before, you cannot move from right to left in a linked list. You always have to move from left to right, because every node has the address to the next node and not the previous node. So how will you know that what is the nth node from the end? So let's say, for example, our n is equals to 2, and our fast pointer and our slow pointer are both on this first node. So what I'll do is simply, if n is equals to 2, I'm going to traverse my fast pointer till the second node. So 1, 2. Okay. So now slow is on the first node and this is on the nth node. So now we will traverse both of these nodes until fast reaches the very end of our list. So in this case, we just have to traverse once. And yep, we reached at the very end of our list for this fast node. So now simply, if you notice, now the slow is at one step behind our target node, because that is what we wanted, right? The nth node from the end of our linked list. So the nth node is this, and this is one step behind. So what we can do is, we can say slow dot next point to that one. Simple. And this node will now cease to exist. So yep, that is what we have to do. Let's try to do this. I'm gonna initialize two nodes. Let slow equals head. Let fast equals head. Then, as I mentioned, I'm gonna traverse fast to the nth position in our linked list. So for I equals 0, I less than n, and I plus plus. Fast equals fast dot next. Now at this point of time, the fast is at the nth position in our linked list after this loop is done, obviously. So, but first we have to check a few edge cases. So if there's nothing inside of the fast, if fast has already reached null, so that means it is at the very end of our list. So I'm going to simply return head dot next. We will remove the first node, because if n is equals to, let's say, for example, for this list, it's 5, it has length 5, right? If n was 5, So that means all we have to do is remove the head. So then we can simply return head.next, that is this node over here, and we will get this list as our output. But if that is not the case, then as I mentioned, we will move both of these nodes simultaneously until fast reaches the very end. So while fast.next has something, or you can say that until fast.next is not equals to null, do this. Fast equals fast.next, and same for slow as well. Slow equals slow.next. Now at this point of time, we are at this position. Now simply, as I mentioned, what we have to do? We have to do slow.next equals slow.next.next. So this will be point to this one. So slow.next equals slow.next.next. That's it, and we can return our head. Let's try to run this. Awesome. Let's submit it. Amazing. So you see how easy linked list questions are in our DSA interviews. You just have to put in a little bit of logic, and it's very straightforward to do questions like these. Let's move on to our next question and our last question, which is adding two numbers. Okay, so the question says that we've been given two non-empty linked lists representing two non-negative integers. Okay, so let's take for example this one. We have 2, 4, 3 and we have 5, 6, 4. So these are the two linked lists that we've been given, and we have to add both of these linked lists. So add the two numbers and return the sum as the linked list. You may assume that the two numbers do not contain any leading 0 except the number 0 itself. We have to start adding from here, because if you see, they mentioned the digits are stored in reverse order and each of their nodes contain a single digit. So we have to reverse this linked list. So we have to assume that this is 342 plus 465, and then we are supposed to give the answer. So if this was the case, let's see, 5 plus 2, 7, okay, 6 plus 4, 10, and you cannot write 10 over here, right, because 1 is going to be a carry. So 1 is going to be carry forward over here. So 4, 5, 6, 7, 8. So then we will get 8. So the sum of both of these will be 708. So this is a little bit tricky. This carry part actually is going to be a little bit tricky. So let's see how we can do this. So first thing first, what we need to do is, obviously we need to create a new node for this new linked list that we're going to be creating. So as you can see over here, they have given us the blueprint for creating a node. So our node is going to be called list node. I'm going to say where dummy equals new list node, and this will have a 0 by default. And then I'm going to have a current variable. So let's just say current equals dummy. So dummy over here is going to be the head of our newly created linked list. So I'm going to store dummy inside of our current variable. Okay, and I'm going to have another variable where carry, which is going to be by default 0. It's going to contain if there's any carry values. For example, over here 6 plus 4 was 10 and 1 was the carry value. This will contain that. So let's see how we're going to use these. So first of all, simply I'm going to run a while loop. So while this while loop will run until this L1 has something or this L2 has something. So L1 linked list, L1 is not equals to null, or L2 is not equals to null, or carry is more than 0. Until that point, this will run. Okay, so let's start by extracting these values one by one. So I'm going to say where value 1 equals, if L1 has something, then I'll take L1 dot value, else I'm going to take 0, because there could be a possibility that these are not of the same length, right? So let's say if at this point of time it was just 5 and 6 and this was 2, 4, 3 and there was no 4 over here. So to replace this 4 or to replace this node, I'm going to take 0. So okay, if we don't have anything inside of it, we will take 0, else we will take li dot value. So we have taken 2 over here. Same for our second list as well. So value 2, L2, L2 dot value. So you can assume that this is 2 now and this is 5 right now. Now after this, simply we're going to add them. So where sum equals value 1 plus value 2. plus if we have any carry with us. Right now we don't have any carry, but you're going to see that how we're going to have this carry later on. So okay, let's suppose that this sum gave us some value which was bigger than 10 or bigger than 9 basically. So let's say if this was 7 plus 7, so 7 plus 7 will be 14, but we don't want 14, right? We only want 4 and we want 1 as a carry. So inside of carry I'm going to say math dot floor sum divide by 10. This will extract 1 from that 14, but we want 4 as well, right? So I'm going to say sum at this point should be sum modulus of 10. So what this essentially is doing is, if we have 14, so 14 mod 10 will be 4, and over here 14 divided by 10 is 1. So we are extracting the carry over here, and we are extracting here the value for our sum. After this, simply if you remember, we created a node over here, current. I'm going to simply add it inside of our this newly formed linked list. So current dot next equals new list node, and I'm going to add this sum over here. We have created successfully a node over here. Now I'm going to say current equals current dot next. I'm going to move on to the next value. Now that is all we need to do. Now in the end we will need to traverse our linked list, right? So I'm going to say if there's something inside of our L1 or L2, so I'll say if L1 has something, then just do L1 equals L1 dot next, same for L2 as well. After all of this is done, we will get our sum inside of our dummy linked list. So I'm going to say dummy dot next. I'm doing dot next because we don't want the first node, right? Because first node was 0. We don't want the 0. We just created it for the sake of creating a node over here. So I'm returning dummy dot next. So let's see what's happening over here is, in first iteration we will do 2 plus 5, 7. Okay, we got 7 inside of our links, our newly created linked list. So our newly created linked list, so this will be 7. Alright, now in our next iteration, if carry is still 0, so no worries, again we're going to do 6 plus 4, but in this case we will get 10 over here. So in carry we will get 1, and in sum we will get 0. So fine, again we're going to create a new node over here with 0. So 7 will point to 0, and our carry right now has 1 inside of it. Okay, again we're going to do the same thing, and this time we have 3 and 4, so 3 plus 4, but we have carry value as well, 1. So I'm gonna add that as well, so it will be 8. So now we get 8 over here, we don't need anything here, and we get 8 here. So now a new node will be created with 8. Just like that, we have created our dummy list, and we don't have anything inside of our linked list now after this. So this will not go inside of our while loop, and it will break it. And now we can simply return dummy.next, and we will get our answer. So let's see. I'm going to run this. All right, let's submit it. Awesome, our solution was successfully accepted. And that's it. That is it for this video. If you like this video, give this video a huge fat thumbs up, and don't forget to go and check out my DSA sheet if you haven't downloaded it yet. It's the best resource for DSA with JavaScript, with all of these questions on all of these topics. You won't regret downloading this ebook, trust me, because it will save you a lot of times that you will spend on going through useless lead code questions.